Hey guys, welcome to your proportional versus non-proportional relationships video. Before you get started, what you're going to need to do is with this page of notes, we're going to be on page 29. Your title is going to be proportional versus non-proportional. And I need you to go ahead and set up your journal as I have right here. You're going to have it kind of in a chart style. It's going to have a proportional relationships column, a non-proportional relationships column. And then we're going to look at these relationships in three different ways. We're going to look at it with a graph. And when you're setting this up, if you need these graphs, I do have a stamp. So come see me and I will stamp those graphs in your journal for you so that way you don't have it looking all like a hot mess. You have your tables portion, and then we're going to talk about what it looks like with an equation. So if you will, take a second, pause this video, and set your journal up just as mine looks right now. Alright, so at this point in time, you should have your journal set up at how I have mine. What we're going to do is we're going to compare a proportional relationship compared to a non-proportional. So if you remember back to your proportional relationship notes, we talked about when it comes to a graph, the proportional relationship must be two things. Okay? It must meet two criteria. It must be a straight line, and it must go through the origin. Okay, so as long as it looks something like this, then we have our proportional relationship. It's got to be that straight line and go through the origin, which we know of as 0, 0. All right, that's a proportional relationship. To be non-proportional, it has to fail one of those two criteria, but more specifically, right now, what we're going to be used to seeing is it's still going to be a straight line. So we're going to see a straight line that does not go through the origin. So looking at graphs, if it goes through the origin and it's a straight line, proportional. If it's a straight line but does not go through the origin, it's non-proportional. So just to give you a quick example, I'm going to set up an example that we're going to use throughout the remainder of our notes. So there we have a straight line, but notice our origin's right here, but it's going through our y at 1 right there. So this is a non-proportional relationship. Okay, so here's our versions of proportional and proportional with graphs. Now let's look at a table. So we're going to create a table. We're going to go with a table comparing time and distance. Okay, we're going to make our table have 3 portions on it. We're going to have our x column, we're going to have our y column, and then we're going to have our constant proportionality column, so our y over x, our k. So here's our x, here's our y, and here's our k that we're going to go ahead and put here. Okay, so let's go through. Let's do the line. Let's have x1, y1, x2, y2, x3, y3, 4, 4. Okay, so remember when we talked about proportional relationship, the constant of proportionality is always constant. So k is always constant. So we know that no matter what we do, our ratios are equivalent, meaning that they're the same, they're equal to each other. Okay, which means we are looking for k to be constant. So if I do my y over x, I have 1 over 1, which is 1. 2 over 2, that's 1. 3 over 3, 1. 4 over 4, 1. So my k is constant because I put my y on top of my x. Now I'm going to use this exact same graph and these points I put up here in my table below. So I'm just going to go ahead and set up this table. So x, y, k. Let's use the point. Let's use this one. So 1, 2, 3, negative 4, negative 1. I'm going to use the point 0, 1, 2, 2, and we'll go 1, 2, 3, 4, 1, 2, 3, 4, 3. Alright, so let's solve for k first. So we know k is our y over x. So I'm going to take my y, which is negative 1, put on top of my x, which is negative 4. That's going to give me a positive 1/4 because negative divided by negative is a positive. So y over x gives me 1/4. Now if I do the same thing on this one, I'm going to put my y, which is 1, over my x, which is 0. This you cannot do. 1 over 0, we talked about in our slope video, would be undefined slope. Now this one isn't undefined, but this one is not something you can do. 2 over 2 is 1. 3 over 4 is 3/4. So if you look at your k, notice ratios are not equivalent. Because our ratios are not equivalent, that means k is not constant, therefore it is a non-proportional relationship. Alright, so we have these pieces set up. Now last thing, let's talk about what it looks like as an equation. Alright, we talked about proportional relationships, or the equation y equals kx. Alright, and remember I said that we're going to see this equation, but we're going to see it written another way. And that's going to be y equals mx plus b. So essentially these are the exact same equations, alright? Because remember we talked about in our slope video, k is the same thing as m. Well, this equation is this equation, but we are used to seeing it like this. This b, this 0, we're going to get into in our next unit, but this is what we call the y-intercept. So this is where the line is crossing the y-axis. So if you look back up here in our graph, our line here is crossing the y-axis at positive 1, so my b would be a positive 1. The reason we're used to seeing this as a plus 0 is because we said a proportional relationship always has to go through the origin. So that means that the y-intercept, where it's crossing the y-axis, is always at 0, therefore we don't need to put it in there. So examples you might see are things like y equals 3.5x, y equals 1/2 x. If it looks like this, or the one way I like to think of it is if it looks like a one-step equation, then that is a proportional relationship. Now if it looks something like y equals 3x plus 4, y equals 3.5x plus 12, or in this case, on this example here, y equals 2x plus 1, then this is a non-proportional relationship. Or, once again, if it looks like a two-step equation, once it's simplified, then it's a non-proportional relationship. So I know this is really quick version of debating whether or not it's proportional or non-proportional. Something you will need for your practice is knowing how to find what we call the y-intercept. Okay, we're not going to focus on this right now, but it will be in our next unit. But go ahead and start putting this to mind, that this b is our y-intercept. So whatever that constant is that we're adding or subtracting to our equation, that's the y-intercept. And then if we're looking at a graph, whatever number the line crosses at, that is also your y-intercept. So this example right here, y-intercept is 1. This example here, y-intercept is 4. This example here, y-intercept is 12. This example here, y-intercept is 1. If any of this does not make any sense, please feel free to raise your hand. Otherwise, if you're understanding it, then go ahead and start your practice. Make sure you submit your answers, and then once you get a 100, you may go ahead and move on to your quiz. All right, guys, have a good day.